Good morning. In continuation with trigonometrical ratios exercise 22b, this was a doubt one of you had asked me in the previous class, so I'll work it out for you. If 5 cos A minus 12 sin A equals 0, find sin A plus cos A by 2 cos A minus sin A. From the given equation, it can be written as 5 cos A equals 12 sin A, or 5 by 12 equals sin A by cos A. And sin A by cos A in the reciprocal ratios I had explained is equal to tan A. So here a right angle triangle, mark this angle as A. 5 by 12 is perpendicular as 5 and base as 12. Therefore, applying the Pythagoras theorem, the longest I could take this as C and this as B. It's not mentioned, so you can take either B or C as the right angle. Okay, and AC will be equal to, here AC I have taken as the longest side, so it will be equal to square root of 12 square plus 5 square, which is equal to 144 plus 25 under the square root, 169, which is equal to 13. Therefore, let me mark this as 13. Now we can simplify what is asked. Sin A is 5 by, or let me write it down, sin A plus cos A divided by 2 cos A minus sin A. Sin A equals 5 by 13 plus cos A is 12 by 13 and 2 times cos A is 2 into 12 by 13 minus sin A, that is 5 by 13. Simplifying it further, this is equal to 13 in the denominator, therefore simply add the numerators. It is 17 by 13 and divided by 24 by 13, 24 by 13 minus 5 by 13, that is 24 minus 5 is, I'll write it down directly, 19 by 13. This is equal to 17 by 13 into 13 by 19. This cancels, it is equal to 17 by 19. Alright, so there are a number of questions of this type in this exercise, that is 14, 16, 15 I have already done, 16, 21, 22, 24, 25, 26 and so on. Okay, most of the questions are of this type, so I am very sure you will be in a position to simplify them this way. Now let us look at question number 21. If Q tan A equals P, find P sin A minus Q cos A by P sin A plus Q cos A. So a right angle triangle again and A. Therefore, name this angle as A. This could be a right angle. It says from the given equation, it says tan A equals small p by q. That means perpendicular side is P and base is Q. So again by Pythagoras theorem, if I name this as C and this as B, AC will be equal to square root of P square plus Q square, right? And it cannot be simplified further. Therefore, substituting the value of AC as P square plus Q square under the square root, we have P sin A minus Q cos A divided by P sin A plus q cos A equals, I'll just substitute the values, p into sine A is p by p square plus q square under the square root minus q into q by p square plus q square under the square root divided by p sine A again. So the same thing, p into p by p square plus q square under the square root plus q cos A plus the same thing. So q into q by p square plus q square under the square root. This on simplification, I'll do it here, is p square minus q square by p square plus q square under the square root, and the sign of division, this one, this sign of division is here. It is p square plus q square by p square plus q square under the square root. This is equal to p square minus q square by p square plus q square under the square root into p square plus q square by p square plus q square. This cancels, the square root ones cancels, and therefore it is equal to, I'll write it down here, the final value of it is equal to, fit in here, p square minus q square in the numerator and p square plus q square in the denominator. So this is the final answer or the expression to this simplified form of this expression. All right.